Hey, welcome to another session with Ackland Avenue at our Ackland Avenue Developer and QA and Product Owner Summit. It used to be just the Developer Summit, so now we're having to expand it into other areas, which I love. So tonight, in this session, last session for the day, we're going to talk about something that's brand new to Ackland Avenue and probably new to a lot of people in our community and for our neighbors. It's called Typescript. And it's something that that Ackland Avenue is going to start really embracing in the coming days, weeks, and months. By the end of this year, we will probably be 100% TypeScript on all current projects. And so we're going to be adding it in slowly with the leadership of Dante. He's going to be helping us a lot with that. And we'll hear more from Dante talking about TypeScript and also bootstrapping a new project that we've got in just, I think maybe tomorrow or the next day, I can't remember, tomorrow. So be looking forward to that. But for right now, let's just talk about TypeScript. So go ahead and share the screen with GitHub. And so everybody in the community has access to this. One thing, if you are looking, or if you're watching the session on Google Hangouts, then you should be able to submit questions if you're out in the community. Of course, if you're here at the summit, you can just shout them out, or you can type them in. If you're introverted, you can just type them into the Hangout there too. But we'll see those questions as they pop up, and then we'll try to answer them. So everybody has access in the world to this repository. It's called the TypeScript cheat sheet. And so several of you noticed this the other day. It just kind of popped up out of nowhere. What happened was Dante found a link to a quick reference kind of cheat sheet, and then we stole it and put it in a GitHub repository and then reformatted it. And don't worry, we gave credit to the people that made it here at the top and at the bottom. So hopefully it's all good and legal. Nobody's going to be knocking on our door. But anyway, it's going to work for us for right now. So if you look at this cheat sheet, it really just gives you some information about TypeScript and how to navigate it. You've got an example of an interface. TypeScript is very much like C# in that it's strongly typed. It basically takes the idea of JavaScript and overlays this layer of typing that's really, really useful for development time. I don't know if you've ever noticed, especially if you're a C# developer or a Java developer, you've run into problems when you get into the dynamic or JavaScript world where you're trying to work and your project's getting bigger and bigger and bigger, and you need to refactor something. You need to rename a variable or a method or a class or a function or whatever. In JavaScript, it's not simple at all. In fact, it can be really, really dangerous. It's so dangerous that you might not want to refactor something. You might not want to rename something when really it does make a lot of sense. Because if you rename it in one place, you got to rename it in 5 other places. This is just one little example of a way that a strongly typed language could really give you a lot of benefit. So TypeScript gives you that over top of JavaScript. TypeScript is basically JavaScript. So all the concepts behind JavaScript are in TypeScript. But it takes it a step farther. So ECMAScript 6, I think, 7, 5, 7. I'm going to go with whatever the newest ECMAScript is. It's coming out very soon, or it's going to be adopted very soon. And TypeScript actually gives us the new version of ECMAScript today. Yes, Dante? Right. Okay. So ECMAScript 6 is what not all browsers support 6 yet. But if you use TypeScript, then you can use the features that 6 gives you. And so TypeScript is just a superset. That's what they call it, a superset. That's kind of above my pay grade. I don't really understand superset, but I understand kind of layer. It's something that sits on top of JavaScript for me as a developer. And of course, you're wondering, well, browsers don't support TypeScript. Well, of course they don't. You've got to compile your TypeScript down to JavaScript. And so that's also kind of a weird concept because usually when you think of compile, you think of you've got your Java code that gets compiled down to some sort of machine language. C# gets compiled down to IL. Well, I looked it up. The definition of compile totally works for TypeScript and JavaScript. So don't get your panties in a wad about that. It actually works just fine. So when you compile TypeScript, it turns it from TypeScript into JavaScript, and it's not ugly TypeScript that you'd expect from some really horrible code generator. It's actually nice. It's actually nice JavaScript that we might write as developers. So it's actually good stuff. We'll see some of that here in a few minutes. So we've got classes, we've got interfaces. We can inject an interface just like we do in C# when we do dependency injection. We can inject an interface and then apply give it a concrete at the bootstrapping level. Very useful. You've got enums just like we do in C#. We've got different types of like you can define an anonymous type exactly the same way you do in C# and in JavaScript. Just change the colon for an equal sign, or an equal sign for the colon. Arrays, again, it's just JavaScript. So you're able to actually use generics, as you can see there in the array of type string. So you can have an array of strings, and when you're developing, when you try to compile, that compiler is going to stop you if you've tried to put something besides a string into that array. That's powerful. Something that you don't get with JavaScript, because JavaScript's going to stop you if you try to put anything else in there. We're just going to kind of browse through the rest of this this GitHub repository, because I actually want to get back to another one of the files that's up in the main root there. It's called from C#. Right there. Yeah. So you all can look at the cheat sheet on your own. It's actually really interesting, and it might be useful for the lab that we're going to do in just a minute. So what I did was I took some time and created a comparison between C# and TypeScript. By the way, if there are any mistakes in this, or if there's any way to make it look better or better in any way, just submit a pull request. This is open source. Anybody in the community can get in here, and actually they already have. There was one person that came in and actually reformatted one of the sections, and I don't even know who it was. I was really grateful for that person, and we put them on the bottom of the contributors list. But you can just look right here. Namespace is the same thing as a module in some ways. As far as like coding terms, you can wrap all your classes in the same module, and it's the same thing as a namespace. Export acts very much like public, as in public class. Export allows you to get that class that you've created out into the global scope. And I think that's not exactly accurate, because there's something about the modules with CommonJS and AMD that it keeps them out of the global scope. But you people that understand that kind of stuff in JavaScript will know better than I do. Static is the same. Actually, a lot of things are exactly the same. Enums are the same. Class is the same. Interface. Really, the people that created TypeScript, anybody know who created TypeScript? Well, I'll correct you there. Microsoft is who created TypeScript. So yes, the creator of C# is Microsoft, but the engineer who is the father of C#, Anders, I can't remember his last name, Anders something. He is now on the TypeScript team. He actually came in later on, so he's there affecting the direction of TypeScript, but he's actually not the creator of TypeScript. He gets the credit for it because he's a big name. But yeah, so Microsoft created TypeScript. It's really focused on you as C# developers, trying to give you what you've been missing in JavaScript. It actually uses some of the same language as Java, like in implements and extends, instead of using the colon like we do in C#. So there's some differences. And this right here, this little syntax right here is really useful, but it's kind of it's hard to understand what's going on there. But it's the same exact thing as a using statement, being able to bring in references from other classes, other modules. And once again, I'm going to let you all kind of look through this stuff. This is all available to you. If you want to see this, all you got to do is go to github.com/Ackland Avenue. And you'll see in the list, if you're logged in without, if you don't have access to our repository as a developer, then you can, you'll see it in the fourth space. Just if you look at github.com/Ackland Avenue, or if you're logged in as an Ackland Avenue developer, you'll see it way far down the list. Just search for Typescript, and you'll see it in there. So this is one of the files in there. One thing that's interesting about Typescript that I alluded to just a moment ago is that you have to compile it. So how do you compile Typescript, and you're working in something like Sublime, or you're working in Visual Studio or Brackets? How do you compile this Typescript? Because we got to get it down to JavaScript so that we can use it in the browser, right? Well, you have to go through a process, and I think it's built into Visual Studio in some ways. If you got the right extensions loaded, you can also add a plugin to, or an extension to Sublime, maybe even to Brackets, and be able to have IntelliSense and compile time checking, and also be able to build in, the same thing that happens when you do Control-Shift-B in Visual Studio. You can actually build your TypeScript to JavaScript, or you can just use a command line tool like gulp or grunt. Here's an example of a gulp task that compiles the TypeScript files in those two folders, and it compiles them down to JavaScript using CommonJS, which is the pattern that you'd use in Node. And then it puts them into a folder, which would be something that we defined as the build folder. So that's basically how you compile this. Now, today for the lab, we're not going to have any kind of complicated compile steps. You don't even have to use an IDE. So all you got to do for the lab today is, and if you want it, it'll make it easier for you if you'll load this repository on your computers, so that you can actually click the links instead of me having to tell you where to go and stuff like that. But if you just click on this link at the bottom of the C# lab, that takes you to the TypeScript playground. It's got two sides, a JavaScript and a TypeScript side. And so you can actually see an example here of a TypeScript class, and then you can see how it converted it to JavaScript. And this is a really cool tool. You can actually see it happening, and it even has some IntelliSense and some checking to show you what a compiler message would give you. Well, the lab is, if you can go back to that screen, the other screen. The lab is taking a string kata that Richard and I did like 3 years ago, and this is the C# version that we ended up coming up with, and it might have been like the fastest kata ever. Richard, I don't remember. Oh no, our record has been broken. Go Pamela. You had the fastest ever string kata? Anyway, that's irrelevant. Erase that from the record. We still have our record. So anyway, here you can just copy the code, or you can just look at this for reference. The lab is basically just to turn this C# class into a TypeScript class, which, using the playground, will then turn it into JavaScript, and then you should just run it. And if it works, then you win. You've finished the lab. That's it. So, any questions? Hey, get to work. And if you're out in the community, you can ask questions. If you have any questions about TypeScript, you can put them in the audience questions, and then I'll come back to the mic and we'll answer them. And after this, we'll just have maybe 2 or 3 people, maybe 2 people share their playground page, just to maybe see how they did. And if y'all want, Dante can maybe float around. Dante's been actually, maybe Dante should finish the lab first, and then he can float around and help. By the way, this is a pair activity. Y'all pair on this. One more time, the way to get to the TypeScript cheat sheet is go to github.com/Ackland Avenue, and then you can search for it in the list of projects at Ackland Avenue. The lab is one of the files in that repository. I think it says C# lab. Make sure that you read the instructions in the lab on GitHub. There's a hint in there for a way that you can actually show that your function is working. So I'll just tell you what the hint is. It's either using an alert or a console log just to show the calculation. Anybody finished yet? Almost time. I need at least one or two that are finished. All right. Very close, very close. Seconds away. I know we've got one. Do we already have two? We got a second one. Okay. All right, cool. Well, go ahead and turn off the music. Camilo, can you share your screen with a projector? Can you load? No, with your laptop. Can you share your screen with a projector? Richard can maybe help you do that. You need to load the Google Cast extension, and then you should be able to display. Actually, no, forget that. Join the Hangout. You need to join the Hangout. Mute your mic, mute your speakers, and join the Hangout for the thing. Osman, same thing. You need to join the Hangout for this session, and then we can share your screen. Go to your Google Calendar. I'll send you a link. Yeah. Big start button in the middle of that. Okay. All right, I got an idea. Instead of that, why don't you all just add those to the Summit channel in Slack, and just add them as a text snippet, and then I'll share it from my screen, and I'll let you all talk about what you did. All right, so I'm just going to go to Typescript Playground. Oh, did anybody notice that I put my answer to the Typescript lab in the GitHub repo? Guess nobody cheated. That's good. All right, who wants to go first? All right, Osman, good job. Okay, Osman, come on up to the front, and I'll put your code up on the screen.
So what do I do?
Just tell us about some of the decisions you made, why you did this or that.
So I copied the C# lab on my Sublime. So the first thing was the export from C# on the beginning. So I saw in the comparison group between C# and Typescript, the keyword was model. So I added model katas. Then I saw in the TypeScript documentation how to make a class. So I created a class string calculator. And I saw that the calculate function on C# was receiving a string and returning a number. So the first if is exactly the same, except that the contains from C#, it was switched to an index of on JavaScript. And the condition is the same, return 0. And actually the rest is nothing related to TypeScript. Actually, it's just pure JavaScript. The subtraction decision is exactly the same, besides the first that you selected on your split on C#. I replaced it by the accessing the first index of the split array and parse it to an int because it had converted to int32 on the C# code. And then I saw you did your sum in a very fancy way, but it's the same. So I just copied the subtraction and changed the decision on the if, and that's it. And then I just called the class at the end with an alert, and that's it.
So if we run this, is it going to work?
Yes, it will work. It should appear an alert or something somewhere.
Sorry, my son is asking for coffee. Okay, so do you, as someone who really likes his JavaScript clean and nice, well architected, what do you think about the JavaScript that was generated from your TypeScript?
I didn't really see it, so I'm just watching it right now. I didn't see what's
Yes. TypeScript always will generate a perfect JavaScript. The default generation implies that TypeScript will generate an if function, an auto-executor function. If you see the line 28, you will see that. Is the default is how we should write our JavaScript. For that reason, not many people follow that rule. So for that reason, TypeScript is becoming popular to write a better JavaScript.
All right, Camilo. Okay, give me just a second while I change this around.
What do you have to say?
Just talk about any decisions you made or anything that was interesting.
What I did like was the way that I was able to create a class with a constructor and also define those methods. And the other thing that I like it that I was able, for example, to do a more clear casting using the number instead of the parse int. And that's all. Yes. Yep.
If I run this, will it work?
Yes.
Awesome.
Bravo.
Okay. Awesome. Woo. Awesome. Thanks for you all making this conversion from C# to TypeScript. Hope you learned something. This is just the beginning, y'all. We're just we definitely want to go a lot farther than just string calculators and converting from C# to TypeScript. We actually want to start letting this infiltrate all of our development. So if you're still with us from outside, you should get out and look at TypeScript. It's typescriptlang.org or .com. One of those, I can't remember. And then if you're inside of Ackland Avenue, then just get ready because TypeScript is coming. Thanks, and this concludes this session, and now it's time for dinner.